Those of you who've been following me closely, you're actually studying this course seriously, will know that I've said several times in the past that I have a 32 gigabyte RAM memory chip for this camcorder, this Handycam. But I'm only using about 7 G of it, which is usually enough for 4 sessions. Sometimes I have to skimp a bit. But the first session of these 4 was so long, I'm going to have to download one of them to create enough space for the 4th session. Now this is the 3rd session, and my camcorder tells me I only have 22 minutes of filming time left before I run out of memory. So this will be fairly short, but it's not too difficult. Now let me give you the main idea again. You're trying to find a PDA that behaves like a context-free grammar. And what is a CFG? What does it do? Well, it generates a string full of terminal symbols, and it does that by using substitution rules. So it's deriving the string starting from the start symbol, and then progressively you use the substitution rules to substitute variables in your intermediate string. You have a series of intermediate strings, and you use your substitution rules to substitute a variable in the intermediate string for the right-hand side of the rule, whose left-hand side is equal to that variable in the intermediate string. And you keep doing this until eventually you get a string that's all terminals. It's just a totally terminal string, and then you can't go any further. And if that string then is said to be generated by the grammar. Okay. Well, the strategy here with the PDA is you create a PDA that does much the same thing. So using your stack and your input string, of course, so you have a PDA. So a PDA has an input string and has a stack. Okay. So what comes in on the input string, that's the string that your PDA has to, in a sense, by simulation in a sense, derive in the same style as a grammar would derive it or would generate it. Okay, so you have your PDA you have your PDA behaved non-deterministically, right? So it's taking all possible branches of all possible strings that terminate in terminal symbols, right? So you, at each point you can split. Each time you make a substitution, you can split. If there are several choices for a substitution, you can split, right? And eventually, hopefully, you'll get a branch where the generated string going down that branch, you can then check if that branch's terminal string, if it can be done. If it can't, that branch dies. But assume a particular branch ends up with a string that's consists totally of terminals, and then you check that branch, that string that the branch generated, matches the input string that comes into your PDA. Okay, and hopefully one of them will match, and if that's the case, then your PDA has behaved in the same way as the grammar. So that would show the equivalence between the PDA and the grammar. And since the grammar generates the language, then effectively so does the PDA. And that's what we're trying to prove. That's the statement of the lemma. All right. That's effectively what I've been saying. I mentioned it before. I suppose it's fundamental, but when I write this out, part of its function for writing it out is to help me understand it well enough to just teach it. So as I'm writing it out, I'm asking it, what does this mean? What does this mean? So that I understand it. So I pick up almost a real-time understanding from just writing it out. But also, it's a record. It's a lot of it is almost, if it gets tight, if the reasoning is tight, it's almost verbatim from the text, but quite a bit of paraphrasing. So you're getting, in a sense, two inputs. You can read the text. You can always freeze. It's a video, right? You can freeze it and read it and study the text, and or you can listen to me, and hopefully the two together will be more powerful than the text. If you're just reading the text, and when I say text, the two texts, there's this text and there's the textbook. Okay, so hopefully my paraphrasing is not making the content, the meaning, more confusing. I'm hoping it's doing the opposite. I hope it's clarifying. But that, you're the student. It's for you to judge. I mean, that's what professors are supposed to do. They're supposed to clarify the text in lectures for students in classrooms. But my classroom is the planet, so I can't bend over one student and say, well, did you follow this? I can't give personal tutorials. Okay, I guess it's one of the disadvantages of this type of teaching approach. But it has the huge advantage that you can rewind. Right? If you don't get it the first time, you can go back and rewind until you do get it. So you have two sets of input. Three actually. There's the textbook, there's the text, and there are my words. All right. Okay, so we've got the broad picture now. So now let's get into the details a bit. How to implement this? Like, do you read in the start variable to the stack? You push it on the stack, and then you just substitute the contents of the stack, equivalent to a substitution rule would work. That's tempting. That sounds like a plausible idea, but there's a complication, and that is a stack. You can only access a stack by what's at the top, right? It's a stack. So the stuff underneath you can't get at unless you've popped it to so that what you do want to get at, that you want to access, is at the top of the stack. So that's the disadvantage. But so what you do is you compromise. So you, like, if you had an intermediate string on your stack, let's say, well, it's quite possible that intermediate string, typically it'll be a mix of terminal symbols and variables, okay, variable symbols. But it could be that what's at the top of the stack is a terminal, and so that's not very useful. So what you do is you have something like this. So if you look at a substitution rule and you see that the first variable in that substitution rule is not a variable. Like, you look at the right hand side, and you're going to substitute that right. How do I put this? Let's say on the stack you have the top symbol is a variable, okay, on your stack, and you're going to replace that variable with the right-hand side of a substitution rule whose left-hand side matches that variable you're going to substitute. So in other words, the variable at the top of the stack. Okay, so you're going to pop that variable, and then you're going to push the right-hand side of that rule onto the stack. But there's a problem there, because when you push the right-hand side, it could be that the top symbol of what's on the stack after you've pushed the right-hand side, the top symbol might be a terminal. Okay, so you've got a problem. So what you do is you compromise. So if what's in the right-hand side, if the first or second or whatever, if you do have terminal variables before your first variable of what's in the right-hand side, well, then you match them directly with the content of your input string. Okay, so you're using the input string and the stack, and so the substitution rule that you're using, you check the first. You check if there are any terminal symbols before your first variable in the right-hand side, and if there are, well, then you match them off against the input symbols in your input string. And if they match, if they don't match, well, that branch dies. Okay. But if they do match, then the remainder of your right-hand side, so that now starts with a variable, that variable and the later symbols, you push that whole thing onto the stack. And so this, what's on the stack now, is your intermediate string minus the few terminal symbols that were before your first variable. Okay, I hope that's clear to you, right? So that's what's going on now. So you've got your PDA behaving like a grammar, in the sense it's using substitution rules and substituting a variable for the right-hand side of some substitution rule, stuff like that. So it's behaving, your PDA is behaving now like a grammar. It's deriving a string of terminals. Okay? Right? And you just keep doing this until using all these substitutions, that you eventually get a rule that matches the input string. That's the essence of it. So I'll stop there.